Every day, we're interacting with all of these digital services, shopping online, streaming shows, connecting with friends. They seem to just work most of the time anyway. But have you ever stopped to think how these incredibly complex systems made up of maybe hundreds of tiny pieces actually keep running smoothly? It's a huge challenge, right? And it's being managed constantly behind the scenes. So today we're doing a deep dive into that hidden world. This session is all about metrics and health checks in microservices. These are basically the essential tools keeping our digital lives, well, functional. We're going to unpack what these terms actually mean, why they're so incredibly critical for these complex systems, and what tools developers are actually using to make it all happen. Think of it as your shortcut to understanding a bit more about the hidden infrastructure of the internet. Okay, so to get started, let's quickly talk about microservices. What even are they? Well, imagine the old way. One giant application, a monolith, where everything's bundled together. Microservices are kind of the opposite. Think of splitting that big application into lots of small, independent services. Each one handles a very specific job. So, like, one service handles logging users in, another manages the product list, maybe another one processes payments. They run independently, which is great for development, but then the tricky part is making them all work together reliably. Right, so if you've got all these little pieces running around, how do you know what they're actually doing? Are they busy? Are they struggling? That's where metrics come into play, I think. Is it fair to say they're like a dashboard for these services? A bit like your car's dashboard showing, speed, fuel, maybe some warning lights if things go wrong.
That's a really good analogy, actually. Yeah. Metrics are basically those quantifiable measurements. They
Yeah.
track the behavior, the performance of each microservice. They give developers that real-time view. So, concrete examples, we're talking about things like, how many requests is this service handling right now? Or how long does it take to respond? That's response time or latency, even stuff like how much CPU or memory it's using. These numbers tell you instantly if a service is slow, if it's getting overloaded, or if it's starting to show signs of failing.
Okay, so metrics give you the current status, the vital signs. But what if a service looks okay according to those metrics, but maybe, I don't know, its database connection just dropped and it's about to fail catastrophically? Is that where health checks fit in? Are they more like a deeper diagnostic, a quick checkup?
It's exactly, precisely. Think of health checks as regular automated doctor checkups for each microservice. They're typically very simple tests. Their only job is to verify, is this service healthy enough to do its basic function? So for instance, that payment service. A health check might just ping its database. Can it connect? Yes or no? Because if it can't connect to its database, it can't process payments, right? So it's fundamentally unhealthy at that point. And the key thing is the consequence. If a service fails its health check, it gets marked unhealthy.
Hmm.
And then other systems, these orchestration tools we'll probably talk about, can react automatically. They might try restarting the service. Or even smarter, they can stop sending user requests to the one that's failed and redirect them to a healthy copy.
Ah, okay, so prevents the user from even noticing there was a problem.
Ideally, yes.
Yeah.
That's the goal. And this combination, metrics and health checks, it's absolutely fundamental. Because you have so many moving parts in a microservices system, keeping the whole thing reliable for you, the user, depends on knowing both the performance and the basic health of every single piece.
Okay, that makes sense. The complexity really drives the need. But let's dig into that why a bit more. We know what they are now, roughly, but why are they truly indispensable? You mentioned the complexity of all these distributed services talking to each other. It sounds inherently difficult to manage. Without this monitoring, are you just sort of guessing what's going on?
Pretty much, yeah. You'd be flying blind. Or worse, you'd only find out about problems when users start complaining, which is way too late. So first off, it's about performance monitoring. Real-time visibility. Let's say your product search suddenly feels sluggish. Metrics will show you immediately if that specific search service has high response times.
Ah, so you know exactly where to look to fix it.
Exactly. You can optimize that service for a better user experience rather than guessing. Then there's quick issue detection. Health checks are brilliant for catching those sudden hard failures. Like, boom, database connection gone. The health check catches it instantly. But metrics also help here by revealing subtle patterns before a hard failure. Maybe error rates are slowly creeping up.
Okay, like an early warning system?
Precisely. Developers can see that trend in the metrics and investigate before it causes a major outage that affects lots of users. This all feeds into reliability and availability. Microservices often depend on each other. If your payment service goes down, like we said, maybe users can't complete any orders. That's a huge impact.
Right, one failure can ripple outwards.
Totally. Health checks pinpoint those unhealthy services so they can be fixed or bypassed. Metrics give you that broader view, helping maintain the stability of the whole system. And it's not just about fixing problems. It's also about scaling decisions. This is really important. Metrics show you when a service is under heavy load. High request rates, maybe the CPU usage is pegged at 100%.
So you know it needs more resources.
Yes. And tools like Kubernetes, these orchestrators, they use these metrics directly. They see the high load metric and automatically decide to scale up, launch more instances, more copies of that service to handle the traffic.
And presumably scale down too when things are quiet.
Exactly. Scale down to save costs and resources when the metrics show low load. It's dynamic. And finally, when things inevitably do break, metrics and health checks are crucial for troubleshooting and debugging. Imagine a user complains the checkout process is super slow. Where do you even start looking?
Yeah, could be anything.
Right. But the metrics might immediately show, look, high latency in the inventory service during checkout. That points you right to the problem area. And a health check could confirm if, say, the shipping calculation service is just completely down or misconfigured. It drastically speeds up finding and fixing the root cause.
It really sounds like trying to run a city without knowing if the power's on or the water's running. You just couldn't do it effectively.
That's a great way to put it. Chaos without them.
So, okay, we understand the what and the why. They're essential. Now, the practical side. How do developers actually do this? What are the tools they use? Because collecting, storing, and then making sense of data from potentially hundreds of services sounds like a pretty big job in itself.
It is, and there are some really powerful tools out there. One of the big names, especially in the open source world, is Prometheus. Prometheus is primarily focused on collecting and storing time series metrics. It can also do some basic health checking by monitoring if service endpoints are reachable.
How does it actually collect the data? Does it, like, ask each service?
Sort of, yeah. It operates on a pull model. Your microservices are set up to expose their metrics, request counts, latency, whatever, on a specific web address, usually metrics. Prometheus is configured to periodically go to that address on each service instance, scrape the current metrics, and store them.
Okay, so it pulls the data in. Then what? How do you see it?
Well, Prometheus itself has a basic interface for querying the data. But more often, you'll see it paired with a tool like Grafana. Grafana is fantastic for creating rich dashboards, visualizing those metrics over time, and importantly, setting up alerts, like alert me if the error rate for the payment service stays above 5% for 10 minutes.
Prometheus sounds really central to a lot of monitoring setups then. It seems pretty popular. Is it relatively easy to get started with? Or is there a steep learning curve?
It's extremely popular, yes. The basic setup isn't too bad, especially with container orchestration systems. The concepts are fairly logical. I'd say the main learning curve comes with mastering its query language, PromQL, which is very powerful but takes some getting used to. And managing Prometheus itself at large scale requires some operational knowledge. But the community support is huge, which really helps. And for developers using certain frameworks, things can be even simpler. Like if you're building Java applications with Spring Boot, there's a fantastic module called Spring Boot Actuator.
I've heard of Actuator. What does that do specifically?
It basically provides ready-made endpoints for health and metrics right out of the box. You include Actuator in your project, and it automatically gives you, say, an Actuator health endpoint. You hit that URL, and it tells you if the service is UP or down WN, maybe checking database connections, disk space, things like that. And it also provides Actuator metrics, which exposes a whole load of useful performance data, JVM memory usage, HTTP request timings, all sorts.
So it does the exposing metrics part for you.
Exactly. And it's designed to integrate really nicely with tools like Prometheus. Prometheus can just scrape those Actuator metric endpoints.
That sounds incredibly convenient for Spring Boot developers, like a zero-effort starting point almost.
Lowers the barrier to entry. Yeah.
Yeah.
Hugely valuable.
Okay, so we have Prometheus for general purpose, open source power, and Actuator for easy integration in the Java Spring world. What about folks running everything in the cloud, like on AWS or Google Cloud?
Good question. The major cloud providers offer their own integrated monitoring solutions. Think AWS CloudWatch or Google Cloud Monitoring. These are services within the cloud platform designed specifically to collect metrics and check the health of the resources running there.
So if my service is running on AWS, it automatically sends data to CloudWatch.
Often, yes, or with minimal configuration. Things like CPU usage, network traffic, disk I/O for your virtual machines or containers are often collected automatically. You can also configure your applications to send custom metrics and set up health checks directly within the cloud platform's tools. They provide their own dashboards for viewing data, creating alerts, filtering logs. It's all integrated into that cloud ecosystem.
What are the main advantages there? Is it just ease of use because it's all in one place?
Ease of use is a big one,
Yeah.
definitely. Minimal setup is often required for basic monitoring. They also scale automatically. You don't need to manage the monitoring infrastructure itself.
That sounds appealing. Are there any downsides compared to something like Prometheus? Maybe less control or flexibility? Potential vendor lock-in?
That's the trade-off, yeah. You get convenience and integration, but maybe slightly less granular control or customization than a self-hosted Prometheus stack.
Hmm.
And yes, using the cloud provider's native tools does tie you more closely to that specific provider. It's something teams definitely weigh up.
So it really seems like there's a good set of options depending on your stack and where you're running things.
Hmm.
Prometheus for that open source control, Actuator for the Spring Boot world, and the cloud tools for deep integration if you're already in AWS or Google Cloud. They all seem widely used, well supported, crucial tools for managing modern applications.
Absolutely. And to kind of wrap up the main point here, these things, metrics and health checks, they aren't just minor technical details. They are fundamentally the pillars supporting reliability and performance, this complex distributed world of microservices. They're what allow developers to actually understand what's happening, to maintain these systems effectively, to scale them intelligently, and ultimately to make sure that when you click that button or load that page, you get a smooth, reliable experience.
It really changes how you think about those moments of frustration, doesn't it? Like when an app is slow or desktop breaks, you realize there's this whole invisible layer working constantly to prevent that. So, thinking about that invisible layer, how might knowing a bit more about this system monitoring change how you perceive the stability or maybe the flakiness of the apps you use every single day? And maybe take an app you rely on, your bank, your favorite social media, whatever. If you were the developer, what kind of data, what metrics or health checks do you think would be the absolute most critical to track to make sure it always works perfectly for its users? Something to maybe ponder next time an app feels a bit slow.